Okay, reaction injection molding is a thermoset process. With the urethane technology, we're using an A and a B, very similar to epoxy. The difference is the high pressure impingement mixing, which makes RIM unique. Your A and your B liquids are being impingement mixed at about 2,500 psi. The reactivity of the chemistry varies, but typically it's rather quick. Typically you have about 10 seconds, sometimes less, sometimes more, with which to get your mold filled. So the cure times can be anywhere from 1 to 2 to up to 5 minutes, depending on the part configuration. So what we're looking at here is a state-of-the-art new RIM molding machine. We've got our day tanks. The urethane comes in drums. It is automatically fed into these day tanks, which are held with just dry air at 60 psi. The liquid urethane is then fed into the metering pumps. There's an A and a B. The advantage of the newer machinery is that we have flow meters, so the urethane can be metered very precisely at very accurate ratios. It's not, the RIM chemistry is typically not 1-to-1. They're unique and individual ratios, 1.31, 1.65 to 1, and so on. The urethane is a product that we purchase from a supplier of urethanes, and it comes in kits. The urethane comes out of the day tanks, is fed into the pumps, and from the pumps they're fed out through the machine out to the presses where we have our mix heads. Out in the mix heads, the urethane is impingement mixed. It's akin to two fire hoses shooting the two components at each other at 2,500 psi inside a mix head, and that's where you get your impingement mix. After the impingement mix, it's just fed into the mold at an atmospheric fill, and once it's inside the mold, that's where the urethane reacts, typically grows a little bit to fill out the cavity, and then sets, giving off heat and cooling. This is a mix head. It's a RIM mix head. The cylinder in the center is just a simple hydraulic cylinder. It pulls the center pin back and forth, allowing the urethane to be dispensed into a mold. Inside the mix head, there's a block out at the very front, and the A and the B chemicals, the polyol and the isocyanate, are impingement mixed at about 2,500 psi in that chamber, and about an inch away from the gate or the entrance to the mold. Once it's high pressure impingement mixed, it is fed into the mold at an atmospheric fill. The mold is not pressurized. As the urethane reacts, usually within a few seconds of entering the mold, it typically grows a little bit, and up to about 100 psi, it creates its own internal mold pressures, thus filling out the cavity. And then the rest of the time is getting heat out of the part, 2 minutes to cure and remove from the tool. There you have a solid, real time. The RIM process has its advantages over other processes. It's a low pressure process. It also uses less energy, so it's a relatively green process. The mold is being pressurized through a chemical reaction. There's not an external pressure or force that is used. Because there's low pressures, there's low tonnages in the press. The tools cost a lot less than in thermoplastic molds, and those are just a few of the advantages.